VISI Reverse is a very powerful tool that allows you to convert point cloud data to mesh and then convert that mesh into solid and surface data. VISI Reverse can be used when there's no CAD associated to a part, as well as compare wear in a production part to the original model. We will start with importing points. You can import point cloud data from almost any software within Wireframe, Points, Import from File. We're going to select point cloud here and choose our point cloud text file. These are basically a bunch of points that are coordinated in the XYZ locations. As you can see, there's thousands and thousands of points here. In addition to point cloud imports, if you have a Hexagon scanning arm, you can directly scan the points right into VISI. Observe in the quick demonstration how the rotation inside of VISI reflects off of the rotation in the reverse engineering arm. Now we will start the process of converting these points into a mesh by selecting the Points to Mesh option. We will start by selecting the point cloud, and you will see a dialog box. You'll see an average distance between points. We'll leave it as a default, but if you make this number smaller, there will be more triangles, and making this number larger, there will be less triangles. During the scan or import data, there may be some imperfections that are causing gaps to be created within the mesh. We'll use the Fill Gaps command to clean these areas up. As you can see by selection, you will see the gaps highlight in blue. You'll see open and closed gaps in here. We're going to select this area, and you can see how it fills that gap in with a mesh. Now we're going to fill a gap on an open side. In this example, I'm going to choose Bridge, and I just simply pick 2 points, and it's going to create a mesh bridge around that gapped area, which would help me in closing it off. This also can be used for simplifying a bigger area to create a gap mesh. Now we're going to go into Mesh Refining. Mesh Refining is used to reduce the amount of triangles in the mesh where it may not be required to have as many in certain areas, such as a plane. In our maximum number of triangles, we will reduce that from 1.1 million to 500,000. The results are the reduction of triangles in a specific area. Next, we have Mesh Smoothing. Mesh smoothing can be used to clean up a mesh where there's rigid areas. The number of smooth cycles, we're going to change this from 3 to 5. This will determine how many cycles we're going to run, and you will see the results and observe the rigid areas are reduced. This will help in creating a cleaner surface later. Now we're going to go into the surface creation commands. We will start with something simple, such as a command like Plane from Mesh. Within this command, we can select seed points, but in this case, we're going to switch to triangles. Within triangles, you can see how you can select the mesh by specific triangles. We're going to turn on this angular deviation area, and you get this little dialog. You can see how my angular deviation tolerance is set to 0.1. If I increase that, I'm going to increase the amount of triangles that are selected. As you can see by the selection here, we're selecting the entire group. And when I go ahead and confirm, it's going to create a planar sheet on that entire group. Now we're going to go into Radius from Mesh. Our selection method for this is going to become seed points. Within here, we're going to go ahead and pick multiple points on where we're going to be creating our cylinder shape from. So in this case, we're going to pick 4 points. And once I pick all the points I want, I right click. You'll see a cylinder automatically be created. You can see how you can adjust the distances and adjust your diameters. So you can make that diameter something different from the original one. And you could turn on the mesh to compare the cylinder to the mesh. In addition to planes and radiuses, we also can use these same techniques to create spheres and cones. For more complex surfaces, I can use the command Mesh to Surface. This command can be used for non-planar based surfacing. I will select the entire mesh method and then choose triangles. Just like with the plane from mesh area, I'm going to use the angular deviations. I'm going to increase that number value. I can see what I can get from 0.1 to 0.5 to 0.75. You can see how there's a higher amount of triangles that are selectable. I'll go ahead and choose this set right here, and then right click. This is going to create a surface for me based on the selection. I'm going to go ahead and remove trimming for this, and you will see the smooth surface that is created. I'm going to repeat this process on the sidewall. This time, I'm going to increase the angular deviation a little bit more. So right now, I have it selected as 5, and you can see how it's going to create that smooth surface on the side. With these steps shown, you can see how easy it is to create surface data off your mesh and eventually make that into solid data. Now we review the alignment command. In cases where the scan data and the CAD data don't match, we can use this command to easily align those areas. I'll start by selecting the mesh, and then I'll pick the solid data. You can also pick a surface and point cloud as well, but as you can see within this command, when I hit preview, it's going to perfectly align those two options together, so that way we can compare them in the next step. Now under the reverse drop down and compare, we can select the mesh or point cloud data and the solid or surface data to be able to do the comparisons. Within here, we're going to hit preview and see a color chart with all the differences. I can select any point on the mesh to be able to compare and see exact differences between the parts.